All right, great to see you all here. My name is Jason Grollo, the Air Miners. A couple of items of logistics. We're going to have our typical discussion for about 45 minutes or so, followed by Q&A. At the tail end, we're going to stop the recording and have a half hour of networking. So feel free to stick around for that if you can. Love to have you so you can get to know each other, not just know of each other. We got a wonderful set of panelists ready for us today. And without further ado, I want to say once again, thank you for coming. And David Koweek, our moderator.
Thanks, Jason. Thanks to all of you for turning out today. My name is Dave Koweek. I'm the Science Director of Ocean Visions. Ocean Visions is a nonprofit based in the US that supports prolific innovation to help solve critical problems at the ocean climate nexus. And we've done a lot of work around accelerating the research and the development of ocean-based carbon dioxide removal methods. So I'm thrilled to join all of you today and to moderate today's panel with three real experts who are working at the cutting edge of measurement, reporting, and verification for ocean alkalinity enhancement. So without further ado, let me introduce our panelists and let's get started. Our first panelist is Dr. Greg Rao. Dr. Rao is the Chief Technology Officer and co-founder of Planetary Technologies, which was a recent X Prize Carbon Removal Milestone Award winner. For many years, he's been a senior research scientist at the Institute of Marine Sciences at the UC Santa Cruz. He's the co-founder and moderator of the Carbon Dioxide Removal Google Group. And after 40 plus years of experience in basic and applied carbon cycle research, he is now focused full-time on CO2 management methods, especially those involving marine chemistry, geochemistry, and electrochemistry. Our second panelist is Kelly Erhart. Kelly is the co-founder and president of Vesta. Kelly's work is focused on the commercialization of sustainable technologies and climate solutions through creative nonprofit, for-profit, and hybrid organizations. She started Vesta in an effort to move 30 years of lab-based research on coastal enhanced weathering out of the lab and into real-world viability testing to evaluate whether coastal enhanced weathering could be an impactful gigaton-scale climate solution. This year, Vesta launched a field pilot in New York State. And finally, Dr. Matthew Eisaman. Dr. Eisaman has spent the last decade developing technologies that capture CO2 from the air using the natural ocean atmosphere equilibrium. He is the Chief Technology Officer and co-founder of EbCarbon, as well as an associate professor at Stony Brook University. Matt received his AB in physics from Princeton and a PhD in physics from Harvard. He was a member of the research staff at Xerox PARC from 2008 through 2011, and a physicist at Brookhaven National Lab from 2011 through 2014. Since 2014, he has also served as a technical advisor at X, the Moonshot Factory, formerly known as Google X. So let's get started, panelists. I'm going to start by asking each of you to tell us a little bit about your organization, and specifically to answer three questions. First, how does your organization do CDR? Second, what does MRV mean to your organization? And third, what are you doing right now for MRV? So let's start with Kelly.
Thanks, David. So as David mentioned, I'm Kelly, president and co-founder at Vesta. We are doing coastal carbon capture to deliver CDR, which is known as coastal enhanced weathering in academic literature. Essentially, we grind natural olivine minerals into sand-sized minerals and add that to coastal areas. When the olivine dissolves in seawater, it forms dissolved cations and silica, and that converts the carbon dioxide into a stable, safe, and dissolved form of carbon called bicarbonate, so alkalinity. So basically, we're enhancing seawater's buffer capacity to sequester and store carbon. What MRV means to us. So we really think about the whole life cycle. So CO2, non-CO2, CO2 equivalents. Are there any methane impacts, for example, of our work? You know, we don't think there are, but it's important to really understand and establish that. So we're analyzing the effects, for example, of coastal carbon capture on microbial communities and biogeochemistry. And then the last thing I'll say about what it means to us is that the geochemistry of olivine dissolution and therefore carbon removal depends on the concentration of the olivine in the area. So sediment transport, or how the grains of sand move across the ocean, is really important to us. So we have to tie together these different disciplines, geochemistry, geomorphology, and technology development, to take these measurements, which are manual today and in the future will be sensors. And then the last question you asked, so kind of what are we doing right now for MRV? As you mentioned, we deployed the first field pilot this summer in Long Island, and we also deployed a small pilot experiment in Massachusetts. Our current model for MRV uses a coupled approach, combining models, so a model-based approach, with empirical data that we're collecting in the lab, microcosms and mesocosms experiments, as well as our field deployments. So we've built an in-house olivine dissolution model called Radio, which is based on a public model called Radii. And we are using that and well-established academic literature, refining it with data from lab and field experiments, in order to calculate alkalinity generation. We then feed that into regional Earth systems models, and then eventually into large-scale Earth systems models, so regional oceans models rather, and then we'll feed that into large Earth systems models so that we can have better kind of spatial and temporal resolution. And so really you can kind of think of it as building blocks. We take lab and field data, we plug that into models. Those models then feed into regional models and then global models. So it's not unlike forestry in that, you're measuring parameters of change in a natural ecosystem and then plugging those parameters into models to get those predictable rates.
Thanks, Kelly. Let's go to Greg next. Again, 3 questions as a reminder. How does your organization deliver CDR, or what are you doing to supply CDR right now? What does MRV mean to your organization? How do you define those letters, and how do you embody them? And then what is your organization doing right now in terms of its MRV practices?
Yeah, well, thanks for having us. Yeah, we take MRV very seriously, because obviously without it, we can't be assured of, actually doing carbon removal. So it is something that all companies in this space have to take very seriously. So for Planetary, we've spent a good deal of time on this. We actually have an MRV protocol that we used in our first trial that we did a few months ago in the UK. It took, a lot of time to put together. It's not perfect, but we are able to come up with an estimate of how much MRV we're doing in a given location, given the MRV protocol that we have. As I said, what does it mean to, what does MRV mean to us? It's obviously very important. And we are very much involved in further refining the MRV protocol that we have. We realize that there's still a lot of uncertainty in doing this. And our goal is to try to reduce that uncertainty through measurement and modeling.
And Greg, I just want to cycle back to the first question in case folks aren't familiar with Planetary Technologies. Can you talk a little bit about how you do CDR?
Oh, I'm sorry. Yeah. Yeah, it is OAE, and we're using magnesium hydroxide as our alkalinity source. So, and the other maybe unique feature here is that we add it via wastewater discharges rather than building our own pipe or our own ship to disperse this. Our initial addition to the ocean is happening through existing permitted wastewater facilities where we add alkalinity so as not to violate any permitted discharge, or any chemical parameters that are required to stay within safe limits.
Thanks, Greg. And let's go to Matt again. 3 questions. How does your organization supply CDR? What does MRV mean to your organization? And specifically in that question, I really mean, what are you thinking about in terms of the responsibilities for measurement, reporting, and verification? Or maybe you think about it in terms of monitoring, reporting, and verification, and are there differences there? And then what are you doing right now to embody those practices?
Yeah, thanks for having us, Dave. So first question, ebb carbon uses electrochemistry to generate alkalinity from waste brine streams. So our locations will be coastal. This means potential partners can be any coastal facility that's already pumping seawater. So that could be aquaculture farms, it could be desalination plants, it could be power plant cooling and so on. And the form of alkalinity we're generating is aqueous sodium hydroxide. And so that basically just gets mixed with the diluted salt water that comes out of our system and goes back into the ocean, where it draws down CO2 and partially reverses ocean acidification. In terms of MRV, I don't think it's important what we think the M, R, and V stand for, whether it's measure or monitor, but I think the way we think about it is the goal is to quantify uncertainty bounds on how much carbon is removed and for what duration, right? And that can be, might be in the form of some sort of distribution ultimately, right? Probability distribution. And like Kelly said, that's net carbon, right? So that means any emissions in the process are subtracted from gross drawdown, and it's not just CO2, it's all greenhouse gases. So the third part, our current methodology is what we call measure, monitor, and model. So there's some more M's. And so what that means is the measure part is on our electrochemical system. So because we're generating aqueous solutions on the system, it's very easy for us to characterize, moles per second of sodium hydroxide at what concentrations using standard chemical sensors. So that we know quite well. And then the second part, monitor, is we also know the rate at which we're dispersing that alkalinity to the ocean through some outfall coastally. And so we just measure, monitor the seawater carbonate chemistry in that near field, kind of that near field mixing zone. And what that's doing is really verifying that the seawater chemistry is changing in the way you would expect for that rate of alkalinity addition, and also making sure that we don't go beyond some set bounds. For example, if we want to keep the pH in that mixing zone below 8.5 for safety reasons, we can use that as a feedback to our system. And then the last piece, modeling. So we work with partners with well-validated regional ocean models to then model the amount of carbon that's drawn down in that process and estimate the uncertainty there. And I think, for people who are new to thinking about MRV and ocean carbon dioxide removal, the reason you want to do that is because the re-equilibration of CO2 in the air with any perturbation in the ocean is sort of weeks to months time scale. By the time that re-equilibration, that CO2 has been drawn down, the alkalinity you've added has spread and dispersed to a degree that at some point you can't directly measure it anymore. And so at that point, you want to rely on models for that last piece.
Thanks, Matt. We've now heard from all three panelists, really diverse technologies, but here's what they all have in common. It's all three of these approaches add a CO2 reactive alkaline material to the ocean. And when the CO2 in water reacts with that material, the CO2 becomes trapped as bicarbonate, which sticks around in the ocean for tens to hundreds of thousands of years. And the sequestered CO2 then creates a localized deficit in ocean CO2 concentration that allows the ocean to take up additional CO2 from the atmosphere. So it's that last step that's the removal part, and that's where much of the complexity around MRV comes into play. So, Greg, in your opening comments, you talked about your initial field trial a few months ago. I'm hoping you can expand a little bit on that and share with us what you learned in regards to how you're going to need to combine measurements and models to do MRV.
Yeah, well, as I said, there's kind of two parts to what we do. We are using wastewater as the medium as to how we introduce this to the ocean. And as it turns out, wastewater is super saturated in CO2. And so, but when we add alkalinity to it, we get a very measurable drawdown in that excess CO2. So part of our MRV is pretty easy because we've got this enclosed system where we can actually measure the reduction in PCO2. But obviously we have excess alkalinity past the pipe, past the beyond the where we discharge the remaining alkalinity. And of course, that's where the ocean alkalinity enhancement and ocean CDR really has to be measured or estimated. So how do we do that? Our initial measurements, our initial thought on this was to use models. The real nub of this, I think, as Matt touched on, was the residence time of this alkalized water and CO2 undersaturated water, the residence time of that in the surface in contact with the air relative to the exchange rate of CO2 between the ocean and the air and the atmosphere. And where you have very long residence times and very fast exchange, obviously that's going to be ideal, because that means there's going to be very little loss of this undersaturated water to deeper water. It's all going to be exposed to the atmosphere. And in theory, anyway, it's all going to be used to do CDR, at least in the immediate time frame that we're talking about. I guess I should also say that whatever alkalinity you do add to the ocean and under saturation you do affect, sooner or later it will contact the ocean just through natural ocean circulation. It may take 1,000 years for it to come back to the surface, but obviously those timeframes aren't of interest to our customers in terms of carbon credits, who obviously want more immediate effects on the atmosphere. So we do need to worry about how long this undersaturation that we create stays in contact with the atmosphere. And to initially get a feel for that, you really have to use models. So we rely heavily on physical oceanography models to understand how that works. That's obviously imprecise and needs to be validated. So we are going to have been and will be using measurements to try to validate the assumptions that go into those models. And I also think tracers are going to play a big role, or a role, in trying to validate models in this context, to try to understand where our alkalinity goes. Does it stay in the surface or not? So that's kind of the nub of what OAE is up to in terms of, or needs to face in terms of reducing the uncertainties of MRV that's applied to it.
Yeah, I think, those of us who are working on this day in and day out know that the MRV challenges around ocean-based pathways are substantial. Matt, you talked on this sort of 3-part measure, monitor, model. That doesn't sound easy. Can you speak a little bit about some of the challenges that you faced trying to develop the technology and methodologies for MRV, and perhaps any insights that are worth sharing with the community?
Yeah, I mean, I don't think it's that there's a huge challenge that needs some technological innovation to overcome. I think it's a tractable problem. It's just we need to improve the interaction, improve the models, improve data assimilation, improve how they talk to the regional models, talk to the global models. But that's a community-wide, like we need the entire oceanographic academic community, and I think they're engaged in that. So it's not so much as any one of the companies specifically trying to overcome those. And so then it's fairly straightforward in some sense, right? You have measurements with some level of uncertainty based on current sensor precision, and you have models with some level of uncertainty, and that's where we are now. And then we just march forward to improve them. But I think even now, it's reasonable. The uncertainty is reasonable. Like we know fairly well in certain geographies what will happen with some amount of certainty. And one interesting thing is also moving forward, like as we think about how to improve it, the sensor networks that you may want that would be optimum for answering these questions, those sensors probably look different. Those are different constraints that you want how those sensors behave compared to oceanographic sensors now, because they're really answering a slightly different question, which is trying to assess the likelihood that some change relative to baseline had to do with this intervention. So I think it's a huge, kind of exciting opportunity for all of us as practitioners to work with the oceanographic community and push it forward. So it's challenging, but not in an overwhelmingly difficult way. You just have to make forward progress.
Matt, can you specify a little bit about how that sensor network, the specifications would need to be different between standard ocean observing and purposes for MRV?
Yeah, well, I mean, so as an example, imagine you have a network of a few sensors out in the ocean, and traditionally what the question we're asking is, we want to know the true value of some parameter like pH at a location. We want to know what is the true value. In this case, in the case of MRV for ocean CDR, what we're really asking is, was there a change relative to baseline? But then the problem is really framed like, I have imagine a coastal location where we're dispersing alkalinity. We know the rate at which we're dispersing it, and we have a model that tells us what should happen, right? Now we have a network of some sensors, and we have a baseline, and then we have the measurement on those sensors after the dispersal. And so the fact that there are multiple sensors in different spatial locations, and we're really looking relative to baseline, and we have a prediction, it's more of a question of what is the probability that the data measured by that sensor network could have possibly not been due to the removal of this amount of carbon. So it's just a different question. And I think what it means for sensors is probably precision is more important than accuracy. If you can eliminate common drift, things like that.
Thanks, Matt. I want to turn to Kelly for the next question, which is all about trying to develop MRV protocols at the same time that you're trying to do some of the fundamental science. How is Vesta navigating that balance?
Yeah, it's a great question. And also just want to completely agree with what Matt was just sharing about sensors and the difficulty in the space currently with the kind of current state of sensor technology and needing to be fit for use and also to be field ready for some of the newer sensor technology. But yeah, I mean, all of this in the OAE space is really kind of leading edge. And for us, that olivine dissolves and removes carbon dioxide when it does has been well established, but how that process happens when you add olivine to a new coastal area, or how you design a deployment for into a coastal area for carbon removal specifically, not just placing sand for coastal resilience or something like that, is totally new. And this first field trial, we're expecting about 500 tons of carbon dioxide removal over the full course of the project's lifetime. And we're really learning about that science, as you said, at the same time as we're using the things we're learning to build our methodology and refine our methodology. So we have the framework for that, and our team's been building that out and using the literature that has established our understanding of it so far. But as we're doing the field science, we're learning about things like which parameters are best to measure, which are actually more practical, and kind of what reservoirs can we measure, and doing the R&D that will actually enable scale with technology development as we build and write this methodology. And kind of as the other panelists have mentioned so far, today it's more uncertain. So we'll be very conservative about those buffer pools today. And as we get more data from the field, and as we are able to develop more precision with sensor technologies, that understanding and the uncertainty will become smaller. But I think it is definitely hard, and though not intractable, as Matt said. And in some ways, doing the science in real time with the field developments and field work is actually kind of great, because we can build a methodology based on not what's practical in a lab, but what's practical in the field, so that once it is done, it'll be set up to scale, assuming all of the experiments kind of go forth positively. So our plan is actually, in terms of submitting a methodology to a certification or accreditation agency, our plan is to be able to use the data from these first sites as a V1 kind of concept note to submit next year to accreditation agencies.
Thanks, Kelly. In this first part of the panel, we spent a lot of time talking about where the three panelists and their respective organizations are right now with MRV. But now I want to pivot a little bit and talk about where you want to get to. What does ideal MRV look like for you? And let's start for this question. Let's start with this question with Greg, but I also want to give Matt and Kelly a chance to respond as well.
Okay, so what is ideal MRV? Well, it's obviously where we have reduced the uncertainty to small levels, I would say. And how do we do that? And what does it look like? I would say ultimately, and hopefully our models will become refined enough so that we can rely largely, but not entirely, on modeling, especially where you have verified that model with a lot of measurements and a lot of experience. The tricky part is that this is going to vary with location. Physical oceanography is going to play a big role in the efficiency here. And we need to understand physical oceanography, what's going on in the ocean, how water is moving and the exchange rates, et cetera. And if we can get enough measurements to sort of verify what the models are telling us, then maybe ultimately we can go to a model-based MRV. But obviously there's a lot of work that would need to go into developing those models, and a lot of verification and proving out that those models are accurate to a certain acceptable uncertainty level. So I would say that's the vision. I also mentioned about tracers. I really think that tracers are potentially important here because they provide a way of measuring something that's associated with what you're discharging that is can be more sensitively measured than the actual alkalinity or CO2 under saturation, et cetera. So I'm thinking that traces are going to be an important part of validating these models going forward, and that's something I've been thinking about.
So just a clarification for the non-oceanographer folks in the room, tracers are additional materials that you would add alongside the alkalinity that don't participate in chemical reactions. So they basically will show you where a water mass travels as as parts of advection and dispersion.
Yeah.
I want to turn this over to Matt, and then same question over to Kelly.
Yeah, I mean, I think it looks basically like I described, but where the measurements and models are improved. And then the question is, what do we mean by improved? So I think on the sensor and the monitoring part, it's that they're fit for use and that you're sort of over time, we're pushing further and further out the distance from the dispersal where we can actually detect a signal against natural variation, right? And then for the models, I mean, so first of all, note when we talk about models, we're talking about models well validated by data that have and therefore faithfully represent reality. So it's you really can't have models without ground truthing with data. But maybe a vision in the future is that that we can all just go and just grab the regional ocean model for the region we are looking at. It's all publicly available and open source, and all of us can sort of grab from a library of well-established models and use them for this purpose. It's maybe at least one vision for the future. And the last part I would add is, like, this is something Ebb plans to do as well, is to have a transparent registry, right? So for every ton of carbon dioxide we remove, we publicly post the data and the methodology used to validate it in a way that people could download that and play with it themselves and see how we got there.
Thanks, Matt. Kelly? Perhaps we've lost Kelly for just a little bit. Okay, I want to take a moment to turn this over. In the meantime, while we hopefully can get Kelly back on the line, I want to turn this over to Matt and just ask a question, which I think you started to touch on in various parts here, but it's basically how much of MRV is an individual responsibility and how much is a shared responsibility for the community, and how do we think about delineation of responsibilities there?
So I think each of the companies and practitioners will certainly have their own MRV internal efforts, and we at Ebb do and I think the others do as well. And that's really just so we have visibility, right? We need to be able to estimate what will the uncertainty be in this verified ton in this region, right? Like we need to be able to do that for our planning. But I think, like we talked about, the challenge and the scale as we scale up, it's much bigger infrastructure than any single company can develop, right? So we just really need to, and I think it's starting to, in the early stages of forming a community in the academic community, and national labs and so on, to produce that structure of integrated observations and models that support it. So I think every company will sort of have their own internal effort to some degree, but it's not like each company will use that to say, here's how much carbon I removed. They may use it to know themselves, but probably there will be a larger structure outside of them for the validation down the road. And it looks like Kelly's back.
It does. I wanted to ask the other two panelists if they had additional thoughts, reactions, differing opinions about this balance of responsibilities between individual companies and shared industry-wide or industry, academia, civil society-wide responsibilities.
Yeah, sorry, I cut out there for a second. My Wi-Fi died on me. I generally don't have too much to add to what Matt was just sharing. I think from our perspective, transparency is really important. And it's a reason that we actually have a hybrid corporate structure. We have a public benefit corporation. We also have a fund that takes philanthropic capital to do foundational research and publish that research into the public. And so for us, yeah, transparency is incredibly important. And I think that for the entire industry, even beyond ocean alkalinity enhancement, transparency when we're talking about carbon accounting is super, super critical. Building trust in a nascent market is fundamental to its growth. So that's incredibly important. And then I would agree that, something like regional oceans models being solved at the industry level seems like a necessary feature of a future world for ocean alkalinity enhancement. Our near-term approach is similar to EBS in that we're working with collaborators to run those models at the sites that we're deploying. But long-term, again, we think this really should be solved at the industry level. In the future, there could be lots of different entities, companies doing ocean alkalinity enhancement of different forms and possible overlaps at field sites. And so having an industry-wide approach is going to be important for that eventual growth.
Thanks, Kelly. Greg, do you have anything to contribute here?
Well, I would say right now, Planetary is our objective here is to satisfy our customer. We do have a customer that's buying carbon credits, and it's important that they approve the MRV that we're doing and that they approve how we're quantifying carbon removal. Obviously, in the future, when we get into compliance markets and more customers and a more public marketplace for this, the MRV, yeah, we are going to have to comply and understand how to verify this in a very open public setting and in a way that satisfies our customer. And in this case, it could be, society at large. So yes, we're very cognizant of the importance of this, and certainly, as this moves into the larger societal marketplace, we are going to have to be very open and clear about how we're verifying this, and it has to be acceptable to the customer in terms of the level of uncertainty that we're operating under.
Thanks, Greg. This business constraint touches on what I want to be the last open question to the panelists before we open it up for audience questions, which is just, how does the MRV that you're doing right now affect business models? And that could be specific to your organization, or you could share thoughts that you think are general to ocean-based carbon dioxide removal. Now I'll just open it up. So any one of the three panelists, please go for it.
I can jump in. Yeah, as we've discussed, you need to measure carbon removal to be able to sell carbon removal. You have to satisfy the customer, as Greg says. And today, we can work with customers across the sort of marketplace who are willing to support early development in the field and work with more conservative, larger buffer pools, and therefore pay a premium to, help early stage companies still be able to meet their margins and have a business that can work. And I think the other component of the business model is that there are some customers who are willing to work, pre-accreditation, and then there are many who are not willing to buy pre-accreditation. And so I think there's a bit of a burden on every nascent company to figure out a methodology and submit a methodology that can work within existing accreditation agencies and certification bodies. And those are inherently slow. So the process there is slow, even for established methodologies where you're just making a slight change to an existing methodology. That can be a year or 2 year process. And on a startup timeline, a year or 2 years is a long time. So I think that there's an element of just needing to really square the circle in a way, and get a proper understanding of the state of play in OAE, and have more industry kind of participation in getting methodologies over the line. And of course, that comes with peer review and publication of data from the field. But again, just some of these timelines are mismatched. So that's kind of important to note. This is a group of some of the folks that are the only individuals doing this work, and that's because it's new, and that's also because it's hard. At Vesta, we do anticipate that if coastal carbon capture works, others will want to do the same. They'll want to deploy projects, and so we are building the technology that will enable others to do this effectively, meaning that they can measure it. And our plan is, within our business model, our plan is to license that to other companies to make sure that it's not just for us, but that we're also moving the field forward. And within the licensing model, we do think there should be stipulations in place that incentivize the ethical sort of operation of these companies. So taking into account the full social and environmental effects of deploying in any location, things like that. And so again, that's in part why we have our hybrid structure, so that we can fund some of our work philanthropically, enable that public research, publish those results, and kind of have sunlight be the best disinfectant for us in the field.
Thanks, Kelly.
I can go next. So I think that, as an example, Carbon Plan put forward a draft methodology recently, right, where there's maybe a kind of discounting based on quantified uncertainty, right? So if you take something like that, now you've established a cost of uncertainty. So once you have that, and then you have the cost, whatever it's costing you on sensors and so on to do the measurements. Now, from a business plan perspective, you just do the rational trade-off, which is to say, okay, MRV costs to get this uncertainty at this discount costs me this much. Are there other ways? So Greg kind of hinted at there may be ways of drawing in CO2 to the alkalinity prior to dispersal in some cases that are directly verifiable. So then now you can just do that rational trade-off. That's maybe one example.
Thanks, Matt. By the way, I think that for people who have been asking, I think the echoing is coming from Matt's background. He's in the airport, which is why you'll notice it goes on and off when Matt is speaking. I think we're pretty much to the point where we can start opening up for some audience questions. And what I'm going to try to do here is to try to identify similar questions and kind of batch them as a combined question for the panelists. And so I want to start by trying to batch Bryce Walsh's and Stephen Schofield's question, which is really about what would it take to accelerate or expedite the MRV. And this were some of the things that Kelly touched upon, but I just want to open that up for folks to see, are there ways that we can get to better MRV faster? And what are those steps, if so?
Well, I can weigh in there. We need more experience adding alkalinity to the ocean. We need more trials. We need models that can help us hypothesize what's supposed to be happening out there when we do release alkalinity. And then we need to go out and measure and try to verify, see if those models are correct. So I really think it's, in my view, experience is going to help us reduce uncertainty and see how well we can do, see what the efficiencies are here in terms of adding alkalinity and affecting CDR. And you can model and speculate all you want, but really what it comes down to is really doing this in the ocean at small scales initially, and then scaling up as you can to really get a better understanding of how to do this and what the efficiencies are and what the uncertainties are.
Yeah, I definitely agree with that. More experience is necessary. Another thing for us that we've run into as a bit of a blocker or a slowdown is just the speed at which samples can be analyzed, the speed and the cost of analyzing geochemical samples when you don't have your own oceanographic institute or academic laboratory that's dedicated to you. That is a real difficulty, right? So as a startup, you are really subject to the timelines that are already in existence at academic institutions and labs that have the kind of equipment that you need to analyze geochemical samples. And so I think one thing that could speed OAE MRV up would be some kind of third-party sort of accredited industry, something of an institute that existed to have the kind of complex analytical tools that are necessary to further the field, but could analyze samples in a third-party way on quicker timelines and at maybe more cost-effective or maybe more expensive if that's what we're paying for. But for us, one of the longest timelines we have and the largest uncertainties is how long it's going to take our sample analysis to come back.
Yeah, I do think there's a huge disconnect between how quickly we need to move to solve the problem, the climate problem, and how quickly we can move operating in existing structures and existing resources. I think we just need substantial additional funding, philanthropic and federal and otherwise, to build up the kind of structure we talked about for MRV and the oceanographic community, just as one example.
Thanks, everyone. I want to move on to a series of questions that are a question that combines related ideas from Jens Hartmann, Kate Murphy, Rick Berg, and Manish Devana, which is all around the risks of adding alkalinity, triggering additional calcification, and thinking about the storage of alkalinity and the sequestered carbon durably. So, how do all of those things relate? How are you thinking about those, and how do you avoid really critical thresholds?
So I guess I can go first. So we're doing tank tests now, basically setting those thresholds so we understand under different ocean conditions what are the limits where you start to get, for example, calcium carbonate precipitation, and making sure that we're not operating near those limits. So another thing you can do is a direct total alkalinity measurement, right? So if you were to precipitate calcium carbonate, you start taking alkalinity out of the system. So if you have enough precipitation, TA decrease, total alkalinity decreases is a warning sign of that. But yeah, we want to avoid that for sure.
Yeah, similar for us. So we measure total alkalinity generated, which already accounts for secondary precipitation. So we also analyze changes in the sediment mineralogy to look for secondary precipitation. But with coastal carbon capture, any secondary precipitation that will occur will happen almost immediately in the sediment itself, where the olivine is placed. So measurements of alkalinity flux already kind of account for this as well. And then that builds on our lab-based research as well.
Yeah, likewise, we know where the limits are in terms of affecting precipitation, unwanted precipitation. So we stay well below those levels, and we have to anyway, because we are discharging through a wastewater treatment plant that has set pH and set chemistry that doesn't really allow us to go to the levels where we would get precipitation anyway. The other part of this is that unlike doing beaker experiments and where you have a static amount of water, when you do this in the ocean, the factor of dilution plays a big role. So you may add material that, or you may cause chemistry or create a chemical situation where precipitation should occur, but because of the rate of dilution and relative to the speed of precipitation, you really avoid doing precipitation. So it's a little different system than doing precipitation experiments in the lab. You have this dilution factor that really rapidly dilutes and reduces the chemical impacts of the discharge. But obviously we have to be very careful that we stay below those limits that cause negative effects.
So let's on that concept about negative effects a little bit. There's some questions in the chat from Seema Somani and Aaron Kozin that relate to environmental impacts. And what we did a whole lot of time talking about is the role of MRV in monitoring for ecosystem impact. So I just open the floor here and just ask if anybody has any thoughts as they relate to the role of MRV in terms of avoiding environmental impacts, or I should say unacceptable environmental impacts.
Absolutely. I think that this needs to be considered really robustly for any solution. Anywhere that we're looking to intervene in the natural environment, we should be aware of the negative impacts. And so for Vesta, understanding the ecological effects of coastal carbon capture have been a fundamental part of our research program. So we started that research in the lab and sort of measured all critters from the tiniest up to fish swimming in the ocean to understand whether there would be any negative or even positive effects in a US EPA certified laboratories, and have found no statistical difference in survival rates or adverse effects there, which is what led us to our field trials. But kind of the way that we're measuring for adverse effects, again, is fundamental to our MRV plan, thinking about the non-carbon impacts. And for us, that means moving incrementally to scale and having a very small pilot that then grows to a larger but still small pilot, and having that incremental growth so that we can measure and constrain variables at each site. And we're also investigating where the introduction of alkalinity may be beneficial to ocean species, right? So if we can reduce ocean acidity locally, what are the potential benefits to local organisms there? So that is another element of our research program in the field is understanding if there are any potential benefits as well.
Greg or Matt, do you have thoughts about environmental impacts?
Yeah, just quickly, we're doing some of the same studies Kelly described ourselves to make sure there are no unwanted negative impacts, but also we try and just stay within natural variation as much as possible. And I think in the beginning with smaller scale systems, that's easier to do. And then at the same time, similar to what Kelly mentioned, we're looking at the potential positive benefit to restoring ocean chemistry and actually using our systems kind of in local regions to improve ocean chemistry, for example, for shellfish farms or similar, right? So then you can view it as using this approach to optimize and restore the chemistry locally, and then the carbon removal is a byproduct in that view.
Yeah, likewise, Planetary is looking at biology, the biological effects of what we're doing. We're collaborating with Dalhousie University and the University of Miami and doing some studies on the impacts of magnesium hydroxide, specifically on biota. And I certainly agree that with Matt and Kelly that there is a potential benefit here in that we're really benefiting the biology by reducing the acidity in the ocean. But nevertheless, we have to prove that in fact, this is either a neutral or beneficial process and we're not doing anything negative to the marine environment. And so more work needs to be done to assure everybody that this is safe as well as effective.
Thanks. I want to turn it over to allow some of the folks from the audience to ask their questions. And I want to start with the question from Anna Madliner. If Anna is still on the line, if you want to ask your question about autonomous technologies.
Yes, I am. Thanks. Yeah, my question is regarding how some of the challenges you addressed could be solved potentially by autonomous technology. And yeah, what do you think limits the usage of autonomous technology at the moment, whether it's just that you don't see the necessity or whether it's a issue in cost or in expertise to operate them? And if, yeah, specific new or existing autonomous technology could help increase the MRV speed, so to say.
Yeah, well, I think it's very important and we're very interested in that. And please get in touch. We're planning to do a second trial next year, and it would be great to have some AUV presence there to do the monitoring. We think it would potentially really reduce the cost of a lot of the measurements that we did initially. And I think there's a very important future for AUV in this context and in doing MRV and validating models. So I certainly agree, and I'm very excited to learn more about those possibilities.
Maybe just to quickly follow up or specify the question, is also if you think the scaling of using autonomous technology is possible and whether the carbon capture company would be the one paying or a potential buyer, and who would be the entity using the tech.
You know, I would say all of the above is possible. Companies could buy the AUVs, or the whole companies could be created around it, providing an MRV, an AUV MRV service to companies like ours, where they would go all around the world and they would be the people that would do a big chunk of the MRV in any given location. So yeah, I think all of the above business models are worth considering.
Yeah, I think it's a really interesting idea. I'd say the reason it's not being used today is because the sensors aren't there. So while you are able to measure small changes in seawater, it's not quite as precise as we need. And certainly the sensors that might have the precision that's necessary are not field ready. You know, they may be used in the lab, but they have not been used in the ocean for extended periods of time. And so there's still development to be done on that. And there's some great work being done in the space. We are partnered with a number of collaborators working on sensor development. Additional Ventures has an RFP out right now for a prize program on pretty much specifically this. And I think AUV and generally automation is a necessary part of scaling MRV because, you know, from our perspective, we're physically taking measurements today. We have scientists scuba diving down into the ocean and taking sediment pore water samples, and that is not going to scale, and it's also very expensive. So in terms of who would do it, I would anticipate that, you know, if the AUVs or some form of automated system were providing this service, it should probably be paid for by the company that's using it. And those costs will probably be baked into the eventual cost of the carbon credit that's sold to the end customer. So in a way, kind of everyone is paying for it, but I would anticipate that the company itself would contract those services. And then the only kind of wrinkle in this thinking is just how these vehicles are integrated into a methodology that would be used by certification bodies. You know, I would assume probably that those vehicles would need to be approved and integrated into that approach, kind of in the early days of thinking.
Yeah, it's definitely interesting to us at just let me chime in really quickly, Dave, sorry. Definitely interesting to us. I would say generally anyone who has MRV technologies or methodologies they want to test out as we start doing pilots, please reach out. We'd love to have people test their technologies at our sites. And then on the autonomous question, like it's essentially, if I imagine a sensor network of 10 stationary sensors, and I have the exact same sensors on the autonomous vehicle, the question is if the autonomous vehicle can move around to make those same 10 measurements more cheaply than the stationary ones, then autonomous makes sense, right?
Great. Well, we have just a few minutes. I want to turn it over to each of the panelists to just share a closing thought. I think we've had a really nice hour-long conversation, lots of really great audience, lots of really great thoughts and diversity of thoughts amongst the panelists. And, what is the one thing that you want the audience to take away with from your perspective in this conversation? And let's start with Greg.
Well, I would say that MRV for OAE is challenging, but as Matt alluded to, I think it's not an insolvable problem. I think we'll be able to do MRV within a certain level of uncertainty. There's more work to be done. Certainly, we invite, as Matt said, anyone who has an idea on how to do this better or faster or cheaper, we'd love to hear from you. And yeah, let's put our heads together and figure out the best way of doing this. And there will be trials going forward where we can actually test out these ideas. And so let's do it.
Yeah, echoing Greg's points there. It's hard, but not impossible. And we've done many hard things, quantifying changes in the natural environment before. So this is a great opportunity for us to really rise to the challenge and unlock a whole new understanding of the ocean and how to interact with it. I think that the fundamental research being done here through this technology development, like any scientific research, is going to open doors for the industry more broadly. And so it's incredibly exciting to hear each of these panelists talk about transparency and rigor in the way that we all have, because I think that really is what can help scale this industry. So the effort for collaboration is very real for us as well. Please get in touch with me. I'm just Kelly at Vesta.earth. If you do want to talk about collaborating on any technology development, very happy to talk. And then the last thing is, just walking away with this thinking more about how do we pay for this kind of work, and what kinds of hybrid funding structures should work within this field, because I think it's a question we're not always asking, and we just assume venture capital should pay for everything in the startup space.
I think Greg and Kelly both said what I was going to say, which is it's a solvable problem. So, but it's going to take the larger community working together to solve it, and we have to do this difficult combination of quickly but carefully. So, I think a lot of it's kind of a fun challenge. Everyone needs to come together to solve it, and I think a lot of good science will, separate from the carbon removal, a lot of good science and understanding of the ocean will result from pushing on this problem. So thanks a lot for organizing this discussion. It was great.
Well, thanks to all three of the panelists, and thanks to Jason for putting this together. Just want to take a moment, maybe come on video, and let's give the panelists a round of applause. And thanks so much for all of your great questions and participation and engagement.
And I've also shared the panelist emails in the chat. If you want to dive into any of the questions that you didn't have a chance to answer, or just really get your feet wet in the area of ocean MRV for alkalinity enhancement. So with that in mind, thanks again, everyone. Thank you to David for providing excellent moderation today. And thanks to Greg, Kelly, and Matt for participating. Thanks, everyone.